right, I think we have a good critical mass to get started, so we'll launch. You have joined Connecticut River Conservancy's live stream. We're really excited to have you. This is our episode 2. If you have missed the first one, you can find it at ctriver.org/livestream, where we'll be putting all of the recordings of all of our sessions. My name is Stacy Leonard, and I am the events coordinator here at CRC. And we're really excited to bring our rivers to you in this new format. Before I get to introducing Ryan, I just want to share a couple of details. You'll notice your video and microphone have been turned off. We do encourage your questions, and that will be done by typing into the Q&A box at the bottom of your screen. So take a minute to find that, hovering over the bottom of your screen. The presentation will run about 30 minutes, so we should have a good amount of time for questions. If we don't get to all your questions by the end, I apologize, but we will share Ryan's email address and you can continue to connect with him afterwards. If you're having any technical problems with Zoom and need immediate help, Aliki is our behind-the-scenes Zoom wizard, and you can call her. So I'm going to share that number now. It's our CRC number, 413-772-2020, extension 207. And we are also recording this presentation, so you can access it later, again at ctriver.org/livestream. So I'd love to introduce Ryan O'Donnell to you. He is our very own water quality monitoring coordinator. He brings a wealth of experience and knowledge from over 7 years of working with CRC and a couple of other watershed groups, which I'm sure he'll tell you about. Fun fact, Ryan is one of the bass voices in the Pioneer Valley Symphony Chorus, and he has been a music and science teacher. But for today, Ryan will focus his attention to helping us understand that big summer question, can I swim in the river? So take it away, Ryan.
Hi, everyone. Welcome. And I live in the middle of nowhere with terrible internet. So hopefully, it'll hold out for this. Anyway, so when I tell people what my job is, that I do water quality monitoring and that I study water quality in rivers, the question I always get is, where can I go swimming, and is it safe to go swimming? So, but that's not all there is to my job. It's just the question people ask the most. So I put this together. This is a little bit about how scientists as a whole, not just me, determine the health of rivers and streams. So here's what I'll talk about today. What affects stream health? How kind of 4 factors that scientists use to assess stream health: habitat, fish, bugs, and water. And then I'll let you know, can you swim in it? And this is a picture I took of the Connecticut River in Windsor, Vermont. All right, so what affects stream health? First, you need to know what a watershed is. A watershed is an area of land that drains to a specific water body. So in this picture, which is one of my favorite diagrams of a watershed, because it's full of fun little characters, but it's also very accurate. The dotted yellow line denotes the outside of the border of the watershed. Everything inside drains to that river and to that bay. But then you can also see there's a little sub-watershed where there's a tributary, that's a river that flows into a bigger river, has its own watershed. So, you know, we're all in these nested watersheds. And everything that we do on the land affects the water in the river. So you can see in this diagram, there's a city, there's a farm, there's a horse, a cow that's very close to the river. All of these things affect the water. However, the Yeti off to the side, sorry, that's my cat, off to the side is not in our watershed, so he is not affecting our river. So what I just said, what we do on the land, that affects the health of the river. And this is a diagram that shows how different land uses, hold on one second. Sorry about that. So this is a diagram that shows how different land uses affect how much water goes straight into the nearest water body. So in this, the blue is evapotranspiration, which is a big fancy word that is a combination of evaporation, which is water that just goes straight into the atmosphere, and transpiration, which is the water that is taken up by plants. And that's nearly impossible if you're measuring to tell the difference. The yellow and the brown are shallow and deeper groundwater, and then the red is surface runoff. Surface runoff is water that as soon as it hits the ground, goes straight into the nearest body of water. So here you can see in the forest, we have almost no runoff. Pasture, we have a little runoff. Suburban areas, we get a significant more amount of runoff. And then in a city where it's almost entirely impervious surfaces, which means that the surface is impenetrable to the water, almost all of it goes to runoff, and the rest of it might evaporate or get taken up by what little vegetation there is. So this gives you an idea of how much runoff makes it based on the land use. And runoff's really important because it's not just the water that's going into the river, it's picking up and it's carrying any bacteria, oil, soap, trash, pet waste, anything that's on the ground, that water can pick up and carry with it. So here's a picture of the Williams River in Chester, Vermont, which is one of the tributaries to the Connecticut River. And here you can see right up against the river, we have a road and we have some farms. There's not really a lot of buffer. And so you can imagine that when it rains right here in this spot, that water is going straight into that river, and it might be carrying with it dirt or salt from that road, fertilizer or manure from the pasture, and there's not really any vegetation to help filter it out. The other thing that runoff really affects is how quickly the water gets to the river. This graph, stream response precipitation following urbanization, shows what happens when to the river when you increase the amount of impervious surfaces. So you can see in the black line, that's the rain that falls. And then the pink line is what would happen to the river level if it was a natural stream in undeveloped land. But as we increase urbanization and develop more close to the river and reduce vegetation that would be able to slow and absorb that water, we get this higher peak with this blue line that's also faster. And so you get things like on the right, which was last April when the Connecticut River flooded several times. Of course, this had to do also with the snow melt, which would compound this response if you had snow also melting while it's raining. And that obviously affects our infrastructure, but also that floodwater is picking up a lot of stuff. All right, so now that you know what might affect stream health, how do we judge it? What do scientists use to assess it? In this section, I'm going to use the Green River as an example. The Green River starts in Vermont and flows down and hits the Deerfield River in Greenfield, Massachusetts, right near our headquarters. We have a big cleanup on it in Greenfield every year. And it's a really interesting river because upstream of Greenfield, it's nearly pristine. In fact, the Massachusetts uses it as a reference river, which means that they judge other rivers based on the Green River's condition. But once you get to Greenfield, it's pretty developed. It's a small city. It's pretty developed, and the water quality gets considerably worse. So this map right here is from the United States Geological Survey, USGS, website called StreamStats, which lets you click on any point in the US and it will tell you things like I have here. So we have a drainage area of 89.4 square miles. The total length of streams, including all the tributaries in the watershed, is 209 miles, which is a lot. If you think about it being fairly small. It's about 75% forested, 10.5% developed, and 3% impervious surfaces. And if you want to look up any stats for your local watershed, you can visit streamstats.usgs.gov. It's a really fun website if you're a watershed geek like me. So first, habitat. So this is comparing a healthy stream versus the least healthy stream, which would just be a ditch. So in a healthy stream, we have trees that are shading the water. There would be other stream side vegetation that can also act to filter out the runoff. There would be cooler water temperatures because it's shaded. You would have woody debris on the bottom. You'd have fish and invertebrate animals living in it. And you would probably have a variety of flows. So you would have deep pools that are really nice and cool, and you would have runs that go really fast and are shallow, and those are all important to a healthy habitat. Whereas you have this ditch in a cornfield, which there's no trees, there's no shade, and you just get this hot water that's really not great for animals, that they wouldn't want to live there. And then a little bit more about woody debris. Is that it's really important at rivers. For many years, we thought, oh, this tree fell in the river, it's gonna get thrown downstream, it's blocking the water, it's gonna take out our bridges, and we took them all out. And it turns out that it's really important for developing those diversity and flows, because we do actually want it to block up the water. We want it to hold back sediment. We want it to make deep pools, and we want to have water moving quickly over it or under it. And so they're just really important. So in this, I have the example of the Green River. So there's going to be a lot of words. Please don't read all of them. You won't know what they mean. There's a lot of numbers. I don't know what they all mean. But what they are is from the habitat assessment of the Green River, this stretch of the Green River and the map that's in light blue, from the Vermont Agency of Natural Resources. And this is just to give you an idea of the kinds of things that, hold on. Sorry, technical difficulties. So this one is an idea of some of the things that they look at. So we have the location, just some notes about observations, and then a narrative description. We have a look at the valley and floodplain, and then a variety of things assigned to that. Then we can look at the green, this is what this reach is called, MO4-0, and some measurements. How wide is it? How deep is it? What's the average depth? How much of it could flood? Is there any abandoned floodplain? What are the percentages of substrates? So what kind of stream is it? What kind of bed material? So they really assess a lot of things. Then we can look at how much erosion there is. That's a really important one. How much buffer there is. So here, there's you know, over 100 feet of buffer, which is great on the left side. Are there any mass failures? So that's a landslide. There's not any in this one. And then also, what is the status of the river? And you know, there's this, it's an F-type river, so it's this kind of wide, shallow river, and it's stage 4, which is stabilizing. So it's in the process of being stable. It was judged fair, and the stream sensitivity is very high. So this is in pretty good shape based on this assessment. Something else you might look at is the fish that live in the river. So we look at what's called a fish assemblage, which is just who's in the fish. And we use something called an IBI, or an integrated biotic index. And it's just a look at all these different things, how many different species, the different types of species, the different niches that they live in. And we also look at how sensitive the species are to pollution. And so I took a couple of examples of some fish that people might like. So like these trouts, people like trout, they like to fish them. And if we look at this table here, you can see that 0% of trout species are tolerant to pollution. That means that if the water is polluted, they're not going to be there. So when you're doing this fish assemblage, you would be looking for trout. 76%, they can handle a little bit of pollution, and 24% wouldn't be there if there's any pollution at all. Also looking at another one, suckers. And you can see that they're a little bit more distributed, so that there are some species that are tolerant, some that are intermediate, and some that are intolerant, pretty evenly spread out. So you really have to know your fish and look up each individual species to get an idea of how tolerant they are. So how do you catch the fish, you might ask? What you do is this thing called electrofishing, where you put a very mild electric current into the water, and it stuns the fish. It doesn't hurt them. They just, they can't swim, and so they float up to the top. You scoop them up with a net, and then put them in a bucket where you can identify them and throw them back. This way, you get a good idea of all the fish that are in the river, and you're not really hurting them. So looking at our example with the Green River, so this blue thing was the whole stretch that we looked at before of that geomorphic assessment. And then this in the purple is the site that we're going to be looking at where they did the fish. So it looks like the Vermont Agency of Natural Resources sampled the fish 3 times between 2012 and 2015. And the fish rated very good, excellent, and very good. So overall, a pretty healthy river. Also bugs. They're not all bugs. They're called macroinvertebrates, which would mean invertebrates, that creatures that don't have spines, that are big enough to see with the naked eye. But we like to call them bugs for short, because macroinvertebrates is a really long word. So we use one of those biotic indexes for macroinvertebrates also. BENTHIC meaning they hang out on the bottom of the river. And so here in the top, you can see some of the insensitive, so they don't like pollution. They're intolerant. So if you see them, your river's doing good. So mayflies, caddisflies, stoneflies, Water pennies are really cool. They're these flat beetles, riffle beetles, Dobson flies. In the middle here, you have the things that can handle some pollution, but not a lot. Dragonflies, damselflies, crayfish, sow bugs, little clams. And then at the bottom, which is, I think, comprised of the grossest of the macroinvertebrates, are the ones that really thrive, or that can thrive in polluted water. So black flies, mosquitoes, worms, leeches. And I think it's funny that, you know, that these creatures, which most of us, I think, don't want around, I certainly wouldn't mind fewer mosquitoes and black flies, really thrive in water that is not doing well. So if you want fewer of those, maybe we should take better care of our rivers. And here's some pictures. We have a caddisfly, a dragonfly, and a mayfly. Of course, these are pretty big things, and sometimes they can be really small. I used to work helping identify and count some of these, and we actually, even though they're called macroinvertebrates, and you can see them with your naked eye, we actually use a microscope because many of them are not much bigger than grains of sand. And so in one little cup, there could be thousands and thousands of tiny little bugs, which hopefully you find cool, and that doesn't deter you from going swimming. So here in our example of the Green River, we are looking at that same site where they sampled fish. And you'll notice that they sampled the bugs a lot more frequently. And that's because it's a lot easier to sample the bugs. Unfortunately, when you do collect them, you immediately preserve them with alcohol, which does kill them, but then they get sent off to an expert to get identified. So here we see a lot of green, which means that it's doing very well, except for we can see here in October 6th of 2011, we had super low density, which is how many there are. And you might recall that in August of 2011 was Tropical Storm Irene, which literally just washed a lot of the bugs out. So we wouldn't expect to see a typical density after a huge flood event. And as you can see, the next year there were even more, 4,600, there were even more. And we actually see this after a disturbance. Macroinvertebrates often come kind of rushing back in to fill in the void. And then we can also just look at the water itself, which is a lot of what I do. So there are different things that we test for are called water quality parameters. And here's a variety of things: bacteria, E. coli, nitrogen and phosphorus, temperature, dissolved oxygen, turbidity, which is how cloudy the water is, chlorophyll, salinity or conductivity, which is how well the water conducts electricity, total and dissolved solids, pH, metals. Those are all things that you can collect a little bottle of water and sample for. So in our example of the Green River, we'll be looking at some results from a volunteer monitoring program that I run for the Deerfield River Watershed Association, which is an affiliate of CRC, and then also was helped out a lot by the Green River Watershed Alliance, which is a kind of new group working in the mostly in the Vermont portion of the watershed. So we sample a lot of sites, but to make it simpler, I'm just going to look at 3, and those are the Heinsberg Road site, which is kind of our upstream site. And then we have a site at a swimming hole in that area at what's called the Timber Crib Dam. And then looking at a site way down in the lower watershed in the heart of Greenfield after it's flown through a lot of Greenfield at Green River Park. So first, looking at the bacteria. So bacteria, we test for E. coli bacteria, and we see large differences in bacteria between dry and wet weather, based on that runoff that I was talking about earlier. When there's a lot of runoff, you can pick up any bacteria, especially in any pet waste, and it can end up in the river. And also, this doesn't apply to the Green River, but if you're somewhere with a combined sewer, where the stormwater and the sanitary sewers are all flowing into the same pipes, you can end up with overflows that discharge directly into the river. But I can talk a little bit more about that later. What this graph shows you is what the average was in dry weather in the darker blue and wet weather in the lighter blue, and for the different years. And you can see the swim standard line. So below that is what we recommend as cleaner for swimming, and then above that is maybe there's a higher risk of getting sick by coming into contact with that water, and so we don't recommend swimming. So you can see that the two upstream sites, pretty good, especially in dry weather. 2018, it rained a lot, so you can, that's why that blue line, like we had some really, really, really heavy rain events that we caught, and that got factored in there. But this Green River Park site, it's always high in dry or wet weather, and that has a lot to do with all the development. Looking at nitrogen, which is a nutrient that can contribute to the overgrowth of algae and salt water systems, and our water eventually ends up down in Long Island Sound, which is salt water. So that's why we monitor for nitrogen, but it does also affect overgrowth of algae, some in fresh water. This is looking at the ranges and the averages, and then we have a goal of just under 0.4. And you can see the same thing, that those two upstream sites in Vermont are pretty good. They're meeting that goal with flying colors. And then we get down into Greenfield, and there's just a lot more nitrogen in the water. Phosphorus is another nutrient that contributes to the overgrowth of algae, particularly in freshwater. You hear them talk a lot about it with regards to Lake Champlain and other lakes, and could definitely affect impoundments on our rivers. This one's interesting because you can see the huge effects that heavy rain had on 2018 numbers. Like I said, we got some nearly flood stage level samples that year. And you can see that it's a lot harder to meet this, this goal. It's a lot stricter. And a lot of the reason why the Green River is not meeting this goal is because of Tropical Storm Irene had activated a lot of those mass failures, landslides where dirt is just tumbling into the water. And that dirt tends to carry a lot of phosphorus with it. Phosphorus likes to stick to things, it loves to stick to sediment. And we can see this here, and this is from 2018, where we looked at turbidity, which is how cloudy the water is, versus total phosphorus. And you can see that the higher the turbidity in every case, the higher the phosphorus. And it's almost a perfect linear correlation for the sites that are upstream of Greenfield, and then still a pretty amazing correlation for sites that are in Greenfield. But I broke them down to see if there was a significant difference, which might suggest another source of phosphorus, but I won't get into that now. Because I know that you're all saying, okay, this is all great, but I thought you were going to tell me whether or not I could swim in the water. Don't worry, I am. So the first one that I alluded to when I was talking about is bacteria. So E. coli is a is a bacteria that's found in the guts of warm-blooded animals. That includes humans. So it's always around. And it is not always pathogenic, which means that it would make you sick. But sometimes it can. But because it's a fecal bacteria, its presence means that it is more likely that there could be harmful pathogens that are present because there's more likely fecal contamination. And it's really hard to test for some of those pathogens, and it could take as few as one organism to make you sick. So what do you do about bacteria? As I showed, that heavy rainfall has a huge impact on the bacteria levels. And so it is a good idea to wait 24 hours for smaller rivers and 48 hours for bigger rivers after a heavy rain before you start swimming. I know that before I got into this job, I kind of assumed that when it had just rained and there was more water in the river, that everything would be kind of more diluted and it would be better. But that's really not true. There's more gross stuff in the water immediately after it rains. And you could visit our website, Is It Clean, to look up results. And so on the one side, you can see there's a map of sites. And then if you click on the little pins, you can look up your site. So here's that Timber Crib Dam site. You can see we had pretty good levels in 2019. And it tells you whether or not that sample was taken in wet or dry weather, so that you can start to see a pattern. Is this site clean all the time, or only after dry weather, or never? And maybe I don't want to swim there. Another thing that can be a factor in whether or not it's a good idea to go swimming is the presence of cyanobacteria or blue-green algae. These blooms usually occur in lakes or impoundments. We had a number of very long blooms in Western Massachusetts last year. You hear about it, Lake Champlain, Lake Menfor-Magog, plenty of lakes. The point is that these are pretty serious, and that the cyanobacteria can release very harmful toxins that are especially toxic to animals. So even if there's a bloom, especially don't let your dog or children go swimming. So if there's a bloom, beaches will be closed, and you should respect that closure. And high levels of nitrogen and phosphorus can increase the likelihood of blooms. So in order to keep our waters clean for swimming, clean of cyanobacteria, you really want to reduce any sort of runoff. Don't use too much fertilizer on your lawn. Plant more trees. That's always a good answer. Another thing is dangerous temperatures. This often happens right the first day it's hot. Everyone's like, I want to go swimming, but maybe it's early May in New England, and that water is cold. And the thing is that water feels colder than air. So there's a little chart to show you this. So cold water will feel cold if it's below 70, even though the air starts feeling warm at 70 degrees. And just because it's hot outside doesn't mean that the water has had time to warm up, especially in that early May. So hopefully we're getting towards the end of that really cold water period. So it's a good idea to test the water temperature before you jump in. Don't just like jump in off a rock, and if it's really, really cold, you could get kind of shocked and have trouble getting out of the water. And if it's cold, if you're right on that 70-degree mark, you really want to take breaks and warm up, sit in the sun, make sure that you don't get hypothermia. There's another graphic about hypothermia. And then another thing that's prominent in our area are changing flows. There are a lot of dams on our rivers, especially our larger ones. And it's important to know if where you're swimming, there are dams upstream. Because if they suddenly release water, you could have a rapidly changing water level, which can be quite dangerous. If you're close enough to the dam, you might see a sign that says, look out, there might be a sudden release of water, and listen for horns. Or it'll say, beware sudden changes in water levels. And if that water starts rising, be sure to get out very quickly, because that water can rise up fast and be very dangerous. All right, so those are the things that have to do with swimming. And I'd be happy to answer any questions about anything that I just talked about.
Great. Thank you, Ryan. That was so interesting. I have a ton of questions. I'm going to give people a little time to formulate their ideas and get them written out on the screen. While we're waiting, I wonder if you could help me with a question that I noticed this weekend. I was paddling on the Ashuelot River in New Hampshire, and I had heard that about a month prior, about 10 cows had fallen into the river. And lo and behold, as we were going downstream, we would start to smell a vile smell. And we came upon 2 or 3 cow carcasses, bloated and full of flies and all. And so we had been swimming a little bit upstream, and it was starting to get hotter and hotter in the day. And we're wondering what kind of effect would a dead animal like a cow have on the water quality and our ability to swim in it.
I don't know the exact answer to that question, but since, rotting flesh harbors a lot of bacteria, it's certainly probably safer to swim upstream of any potential dead animals. And that smells a pretty good clue to you as a human to stay away. That this, we evolved to know that those things that smell bad could be quite dangerous.
Right, for sure. Okay, so we have our first question. Kathy asks, why do we care about conductivity, and how does the electricity flow affect water quality?
That's a great question. Conductivity is a measure of how well water conducts electricity. It turns out that pure water, just H2O and nothing else, which is really hard to encounter in the world, doesn't conduct electricity. It's actually the things, ions, bits of molecules that are dissolved in the water that conduct the electricity. And conductivity is kind of our catch-all test. So in addition to things like salt from roads or whatever, driveways, getting in and making the water more conductive, anything that's contaminating the water could be adding more ions. And so there's not really a standard for it. There's not really a good or bad level of conductivity, but what we can tell is that if it changes suddenly, like if you're measuring along a stream and you come to a point where suddenly it's a lot higher, but none of your other tests are showing that there's a problem there, that maybe you should be looking into other things. So, nitrogen and phosphorus can increase conductivity, but also metals, and anything that can dissolve in water. It's also a really easy test to take. So it's really quick, and the meter is fairly inexpensive. So it's great to just keep doing and keep an eye on things that you might not be testing for.
Great. Don't forget, everyone, you can type your own questions in the Q&A box or leave a message in the chat box. You mentioned earlier that the Green River is a reference river, and I was wondering how a river gets that designation and why the Green River in this case.
So the Green River is one of the least impacted kind of larger rivers in Massachusetts, especially at the state line, which is right where they test. It also has a long-term data set. They've been, USGS and the state have been monitoring there for many, many years. They have a flow gauge, so you can check what the levels and the temperature are at any time on the USGS website. And so they use it because they have all that data, and because it's so so little impacted by the at the gauge site. They use that as a reference.
Great, thanks. Great, we have some questions coming in. William asks, is the presence of leeches and small snails in a small lake an indication of poor water quality? In the past, we've always had excellent water quality tests. Not sure where he's writing from. But.
So the thing about them is if you looked at all of the macroinvertebrates, you only had leeches and stuff like that, then that would be an indicator of poor water quality. But if you have a healthy mix of other less pollution tolerant species of macroinvertebrates, so looking for those mayflies, caddisflies, stoneflies, and beetles, they are an indicator of good water quality. And so a healthy ecosystem would have a mix of different species, whereas if you only have those tolerant species, if you only had leeches and mosquito larvae in your lake, then that might be an indicator of poor water quality.
Makes sense. And a related question, would we find the same microinvertebrates in the Connecticut River as in smaller rivers?
No, you find different macroinvertebrates based on kind of the habitat. So different creatures can tolerate different flows. It's a lot harder to hold on to your place in the river on those tiny rocky headwater streams than it would be if you were in the Connecticut River, which is kind of moving a lot slower sometimes and might have a sandier or muddier bottom. So you would have things that like to live in sand and mud, whereas in that headwater stream, you'd have things that are really good to hanging on to rocks to keep from washing away.
Angie asks, sometimes in the spring you see dead fish in the rivers. Is that a sign of bad river health, or is that the natural fish life cycle?
Well, it depends on the fish, but in our rivers, especially Connecticut, in the spring, many fish are swimming upstream to spawn, and they die after they lay their eggs. And so seeing a bunch of dead fish in the spring, if they're shad or other anadromous fish, that's fish that switch between fresh and salt water, then that's okay. A related thing that I get asked a lot too is in the fall, you might notice that your rivers are getting foamy, and you might think that that is a sign of bad water quality. But it turns out that leaves, when they fall off the trees and start dissolving, put surfactants in the water, and surfactants is what makes soap bubbly. And so it's actually just natural leaf decomposition that makes the water bubbly. So seeing dead fish in the spring is okay, and seeing bubbly water in the fall is okay.
Woo. Don asks, are communities taking steps to reduce runoff from roads, and can you share examples if available?
Yeah, certainly some communities are. Vermont has a really strong back roads program. You can imagine that they have a lot of dirt roads, and they realize that also many of their dirt roads are right along rivers. And so there's some really strong regulations in place that require stone-lined ditches that help curb the sediment runoff from dirt roads. In many areas with winter and salt, you know, the primary concern, if it's not a drinking water area, is human safety. And so they really pile that salt on, and often that goes right in the river. And we see that in conductivity and salinity results. And it's not great. And many lakes are actually increasing in salinity levels constantly in the Northeast. So it's definitely something that I really wish that more communities would do, use less salt, and then use green infrastructure that would kind of slow down road runoff and trap some of that salt and sediment.
Yeah, I was wondering also as a follow-up to that, and what you showed in the graphs of how high the levels of phosphorus and nitrogen were in the Green River recreation area in the park there, if there was more being done in that area to combat that specifically, since it looked like over several years it's been high.
That site is actually not the recreation area. There's a Green River Park where there's like the dog park. So it's much further downstream than the recreation area. So don't worry about that. They test the bacteria themselves, and they would close the swim area if the bacteria is too high. But you know, there's a lot of different things. Like a lot of that phosphorus is coming from sediment upstream, so that's hard to combat. But you know, you have to look and see if there are farms and hayfields that are right up against the river with no buffer, no trees, and like tall shrubs to keep water, to maybe soak up some of that water. Then that's something that they could do to reduce runoff. And then also something that's pretty surprising in Greenfield, but is true of the Green River and many rivers around the Northeast and probably the world, is that one of the tributaries of the Green River, called Maple Brook, was actually buried under Greenfield. And so it's just kind of like put in a tube, and it's directly hooked into like our storm water. The drains from the streets go right into Maple Brook. And that one, I didn't have the results on there, but it often is off the charts in comparison to any other site in the watershed. And so we could definitely be doing a lot more to reduce our stormwater impact on the Green River.
Great. Is that one of the sites you could find on the Is It Clean, or there's another place to see that if someone wanted to look for?
Yeah, you can look up. Yeah, you could look up the bacteria results. Spoiler alert, they max out the test every time.
Oh, okay. Yikes. We have a question from Bill and Marcia. Can we swim safely in the Connecticut River at the Longmeadow Yacht Club site?
So we have we do tests there. And so you can look up the bacteria results for that site. And then the Pioneer Valley Planning Commission, I believe, tested that before. So I think we have a site there. But we have them up and down the Connecticut River. So I'm not familiar, you know, with that site exactly, but I would look up the results. And like anything, especially the southern portion of Massachusetts is impacted by those combined sewer overflows that I mentioned before. So definitely hold off on swimming after heavy rains.
Great. Well, that looks like all the questions that people have peppered us with. If you think of anything else, you can share it directly with Ryan. He has his email address on the screen there. And I'll be following up with an email to you all with Ryan's email again, and the location where you can find the recording of this live stream episode as well as all the others. It is ctriver.org/livestream. And as you may or may not know, we're running live stream every other Wednesday throughout the summer and possibly beyond. So stay tuned for more episodes, and you can find all those from our event calendar as well as that live stream page I just mentioned. In the follow-up, I will also be putting in a survey. We'd love your feedback, your suggestions for other topics that you'd like to learn more about, anything else you'd like to share. So I want to just thank everybody for joining us today, and especially to Ryan for sharing all this great information and sparking our curiosity about all the different ways that we can determine our river health. And also to Aliki Fournier, who is our little wizard on Zoom, helping to make this show go smoothly. And I just thank you everybody for joining us, and we hope that you continue to stay healthy and safe, and we hope to see you next time. Thanks.